Okay, we're going to be talking about some various ways to do numeric integration. And one of the ways that we're going to look at this is we're going to use something called the trapezoidal rule. Now, there are some complex integrals that you can't really use a table of integrals, if you will. So you have to find some way to be able to integrate them. And so what we're going to do is we're going to see that numeric integration, we can definitely use some techniques to be able to find the integral. All right, we're going to take a look at some really simple examples here. We're going to start off with this integral here from -1 to 1, and it's just a simple one, x squared plus 2 dx. Okay, but what we're doing here is we're going to basically be inscribing these trapezoids inside, and we're going to be taking the sums of the trapezoids, the sums of the areas of the trapezoids rather. And to do that very simply, we're going to follow this formula here that we see outlined in this box here under the trapezoid rule. All right, so what we're going to do, you've done like Riemann sums before. We're going to calculate delta x here. All right, so delta x is just the change in the limits of integration over the number of panels that you'd like to use. So here we're going to do a trapezoid rule with 4 steps. So I'm going to write that in here, 4 steps. And for the second problem, we're also going to use 4 steps. So this right here will help us determine our size n, okay, because we're doing 4 steps. So let's figure out the delta x here for this problem. We're going to take 1 minus a -1, and we're going to divide it by 4, the number of steps that we need. Well, this becomes basically 2/4, which is 1/2. So what we're going to do is we're going to have increments of 1/2 for each of our x values from -1 to 1. And then we're going to compute a table of values so that we can fill in the formula here for the trapezoid rule. So let's go ahead and take a look at that. All right, so I have my table x and y, and I start off with a -1, and I'm going to be doing increments of half. So the next one is going to be -1/2, followed by 0, followed by half, followed by 1. And what you're going to do, and you can use your calculator for this, is you're going to plug in these x values here, and then you're going to write down the y values. So I've already taken that work out of it for you. So if you've got a calculator handy and you want to work along, definitely by all means go ahead and use your calculator and fill in the table. All right, but I've already done all of that hard work for you. So what we're going to do now is we're going to use the trapezoid sum rule, and that is to say that delta x is going to be divided by 2. So we're going to take our delta x, which is 1/2, and we divide it by 2, and then we're going to take the y naught, which is the first y value here, which is 3, plus 2 times all of the y values in between, and then the final y value will be just the y value by itself. So let's go ahead and take a look. So it's going to be all of these here. All right, all of those are going to get doubled. All right, all of those are going to get doubled. All right, so it's going to be like this: 2 times 2 1/4, plus 2 times 2, plus 2 times 2 1/4 again, plus a single 3. Okay, and so the 1/2 divided by 2 is the same as multiplying by 1/2. And then when you take the sum of all of this data in between, all right, well, what do you get? Well, there you get a total of 19. So you end up with 1/4 times 19. So your answer here is 19/4. And this right here is the trapezoidal sum, okay, using the trapezoidal rule. And so really there's nothing to it. So let's go ahead and take a look at another example applying basically the same technique, okay? And it is the same technique. So let's look at the next one. We're going to call this one number 2, all right? And so we're going to integrate here from 0 to 2, and we're going to take x to the 4th plus 9 dx, okay? And again, here we're going to do 4 steps again. So I'm going to write that down. All right, and I'm going to highlight that just for your reference. Okay, and we're going to calculate our delta x. Okay, so we have, in this case, 2 minus 0 divided by 4, which is 2/4, which reduces again to 1/2. So this is our delta x, if you will. So we're going to compute our table, and we're again going to go from 0, and then we're going to go to half. Okay, because each step is a half. 1, 1.5, 1.5, and 2. All right, and then again you fill in your table values. So the first value is going to be 9, followed by 9.0625, followed by 10, followed by 14.0625. Now I'm going to mention a word of caution here. When I did this one on the calculator, I got 14.063. What you're going to want to do on the calculator is be sure you select the y values and then read the data, the output line at the bottom, to be sure you capture as many digits as you can. Okay, and then when you plug in 2, of course, you're going to get 25. All right, so we've got our values, and now again we take our delta x, 1/2, and we divide that by 2, and we multiply it by the sum of the numbers, except, again, these right here, these intermediate ones are going to be doubled. All right, but the ones on the ends are single. All right, so 9 plus 2 times 9.0625 plus 2 times 10, almost forgot that. Okay, 2 times 10 plus 2 times 14.0625 plus 25. Okay, we've got that there. We have 1/4 basically, and we are going to multiply that by the sum of all of this. So I'm going to tell you that the sum here is going to be 100.25. So I end up with 100.25 over 4, and I'm going to, let's see, what can I do? I'm going to multiply this by 4 over 4, because that will clear my decimal in the top. And this is going to give me 401 over 16, which works out perfectly for me. Okay, so again, really nothing to it. All right, just a really simple formula that you can follow using the trapezoidal rule to do some numeric integration. All right, really neat. So as always, I hope this video was helpful, and remember, like and subscribe.